All right, so we're starting out pretty basic. Most of this you are probably going to already know. The back end of our notes, and they're going to always be sort of geared this way. It's going to start super basic and introductory with some definitions. At least this is my goal anyway, especially if it's newness to us, or like in this case, in the beginning, we're not really reviewing stuff. And then as the pages go down the line, you're getting closer to what I need you to take away as like a Math 3 level curriculum. Because a lot of this math, you have a lot of math in your brain, and you've covered a lot of math in Math 1, Math 2, 8th grade math. So all of that stuff is going to come to light again, or a lot of it. And then we just need to know which portion of it is really pertinent to us and our EOC, and the style questions that you're going to need to be ready to answer. If you did take the Math 1 EOC, I know a lot of you didn't because of COVID, but if you did, and it was terrible probably for most of you, the quality of questions were really hard. I would say Math 3, there is a little bit of a jump in quality of questions, but a lot more is just having number sense, a mild amount of number sense, and then understanding what the question is asking for, because you already had the information probably in your brain. If it's not from me or from our class, you have a version or a small token of it from a previous class, because math is math, and you have a lot of it already covered, like I said already. That's the perk to get into a higher math class, is you should have some in your back pocket. Speaking to the EOC before we get on, just because you are going to enjoy this information, your EOC will be at the end of the semester. It will be on campus. We don't know the dates yet, or which campus necessarily. I don't think is finalized at the moment, but it will be during final weeks. You will have to show up. It will be 20% of your final grade, and you only actually need like 15-ish to 16 questions correct in your back pocket when you walk in that door to definitely pass the test. And I will call out types of questions, and you will see a lot of EOC style questions between now and then. So 10 to 15 for passing, it should be no problem. Or I can promise you we see 10, and then you just have to dig around for 5 more when you're guessing, luckily, on the next, over the 60 questions, 3-hour-long test, which I think all of us can do as long as you're using Desmos and giving some good thought. All right, so to jump into today's notes, so we are working on parent functions, domain range, increasing, decreasing, positive, and negative graphs. That's going to be the overhaul of today. As far as parent functions, my notes didn't get hard into parent functions today, because the end of the day, parent functions, all you need to know visually is it an absolute value? Is it linear? Is it quadratic? Is it a cubic function? And you always have Desmos. So if the equation itself you don't recognize, if you type it in a Desmos, it will graph it. So visually, you need to identify those. I will drop in the box a website that has just a page of parent functions, and that page, actually I'll probably bring it over and you can see it. Sorry if that made you dizzy. So parent functions, it gives you the equation, what it looks like. So obviously linear, gives you the name, if it's an odd or even function, or obviously neither because it's not to a power, or anything of that nature. Then it also starts talking about in behavior that's a little ahead of us right now, domain and range. And this is the parent function in its most purest form. And so this is just a printable sheet that if you would like, you could print it and have in your notebook for reference. In behavior, like I said, we're getting into it later. Their range is maybe written a little different than ours would be in our class, because there's lots of other notations. We don't do a lot with this greatest integer style function. We will get into rationals. Not so much rational inverse squared, but rationals, exponential, logarithmic, cubic. So from here up, you definitely want to know by visualizing what the parent function looks like and what that base equation is, because later we're going to get into transformations and slide these guys around and flip them over. But I will put this in the chat box, and if the Ed puzzle, I will put it in the Ed puzzle in the event you would like to print this guy. Because again, I feel like it's just visual. You have to learn, memorize sort of what they look like, practice with them. So vocabulary things you do know. In order to graph an equation, you need to plot x and y points. X values are the first variable. So the x, they're in alphabetical order. So that means you're going to go right, left first. And then y values are the second variable in the coordinate. And if we're discussing as far as in an equation, some other words to kind of help you find your x, that variable is going to be in the equation. So this is the input. This is what you can control. This is what you go put in the x in the tab. Like if you're looking at a table, you go pick the x value to go find the y value. So input is what you control. So it's the input and it's the independent variable. Independent because it is not dependent on anything else. You choose it, it jumps in, and then it changes your y value, which is your output. And the dependent variable, again, these are throwback vocabularies to like Math 1. And it's dependent because it depends on which x value you look at. To find the y value, you plug in the x value into the equation, so plug it in. So if you only have an equation and you have to do it algebraically and you need an output, you plug in the x value you want. Again, the cool part is we have Desmos, so you can type in the equation and we will eventually figure out, if you don't already know, how to go get a table out of Desmos, and you can find. You plug in the x value into the table and the y value just pops out. Really cool part about Math 3. All right, new. So a set of ordered pairs. So that just means an x value and a y value. So relation is just any set of ordered pairs. It does not matter. Every ordered pair is a relation. A function is a relation where no x values repeat. So there can't be any x values repeating. So no x value can happen more than once. Y value can happen more than once. The x value cannot. So if you're looking at a table, you can't type in 2 in the x column twice and have 2 outputs. So input can only happen one time. Vertical line test. So that's where we're doing one of these. Vertical line test. Hopefully maybe one of your teachers along the way has shown you with a pencil where you're going like this and you're going to touch. And the test determines whether a graph is a function. So whether it goes from a relation to a function. So relation is super vague. Function is starting to get a lot more detailed. Function means that the x value does not repeat. So if you take your pencil or a piece of paper and you go along the graph from left to right, it should never touch the graph twice. And this test determines if the x values repeat. So vertical line test, this is a function. Vertical line test on this guy, this is not a function because it touches twice. Like your y-axis shows you that it touches twice here for a vertical line test to decide if it's a function. Horizontal line test, so horizontal is this way, left to right. A test determines whether the blank of a graph is a function. So the inverse, we're going to get into inverses a little later. Inverse just means the opposite. Remember, you've heard that word inverse when you say inverse operations. What's the inverse of addition? And you would tell me subtraction. What is the inverse of division? And you would tell me multiplication. So the same thing happens with functions. So it just sort of all your x and y values flip to undo each other, I guess, in theory. That's how I teach it in Math 1 with inverse operations. You undo when you're solving equations. So same, your x and y values, so x and y become y and x. Don't overly harp on the word inverse right now or the types of functions. Just visually understand that you can use a horizontal line test. So going this way, and if it only touches once, that lets them know if the y values repeat, which does mean that the inverse is a function of this. Standalone, it is not. If we are calling this the inverse of a function, and I'm sorry, these two are not perfect inverses of each other, but pretending like if this was the flip of that, if the y values do not repeat, then it is a inverse function, not an inverse relation. So inverse, again, we'll get into in detail a little further along in the class, but just understanding horizontal line test and vertical line test. So horizontal is for your inverse functions. Vertical is for functions in general. So one-to-one function must pass both tests. So both vertical and horizontal. So one-to-one means both of those. So this case, this does not pass your vertical test, but it does pass your horizontal, so it is not one-to-one. But if you think about a linear graph, just a straight linear graph, it's going to pass the vertical, and it also passes the horizontal. So the y's never repeat and the x's never repeat. So no x or y values repeat. Then it is a one-to-one function. Now, domain. So again, input. So that's your x values. The set of x values, of a relationship x, y. So just domain. Domain does not have to only deal with functions. It can be points. It can be coordinates. It can be a table. Domain is determined by reading a graph from left to right. So you're looking left to right. How far left does the graph go and how far right does the graph go? And if you're thinking left to right, that is the x-axis. So the only numbers you're going to pay attention to in the conversation of domain is the x-axis. Okay, so range is output, which lets us know that's y values. So the set of y values of a relation. Range is determined by reading the graph from top to bottom, or like I always say, up, down. How far does the graph go up versus how far does the graph go down? So that would be your range. Again, up and down, if you're thinking about up and down, that's your y-axis because that's the only one that goes up and down, and those are the values you can read up and down. Hence the reason range is y values only. So moving right along to page 2. Looking at a list of coordinates, this can also live as a table. It can live as a diagram. End of the day, domain, you're going to make a list. So all of the x values, so 0, 1, 2 would be the domain. And that is every value in between 0, 1, 2. I'm sorry, they're coordinates, so it's not every value. So it has to be written as a list. It cannot be written as an interval. So it's not between 0 and 2 because we don't have 0.5 or 0.75. These are actual coordinates, and they haven't necessarily connected them to make them align or tell us that they're aligned. So the domain is 0, 1, 2. Range is going to be your y values. So 3, 5, 8. So 3, 5, and 8 for our y values. So range, this is just the y values that work for this table or that are used in these coordinates. Domain is the x values used in these. Is this a function? So again, you're just looking to see if the x values repeat. I have 0, 1, 2, no repeat. So yes, it is a function. Is it a one-to-one function? So does that mean the x values don't repeat and the y values don't repeat? That's 3, 5, 8. They do not repeat. So yes, it is a one-to-one function because x values and y values do not repeat. Looking at the graph, this looks a lot like the other one. It's just a lot wider. So domain. The easiest way for me to get most of you to understand domain, because a lot of people still struggle come Math 3, x-axis only. The only thing you're looking at how far to the right does it go and how far to the left. So how far to the left it goes, it stops right here. And then we have arrows on the end. So with these arrows on the end, that means it goes forever in this direction and this direction. We're just looking at a portion of the function. So if we're discussing left to right, how far left? This is 0. So it goes to 0. And then this is positive infinity. And let's get through this. This is negative infinity. So since we're talking about domain, how far right and left does it go? As far left would be 0. It does touch 0. So it's going to be a bracket, not a parentheses. I think about brackets like bricks. Like I can stand on it. I can stand on 0 and be standing on this function. And then it goes towards positive infinity because it goes on forever. Positive infinity is not a place you can stand on or that you can touch or you can grab. So that's why it's the parentheses. That means it just goes in that direction or gets so incredibly close. Visually, it could stop there if we're starting to look at other things. But that's why you have a parentheses there, is you can't hold it or stand on it. Bracket when it's a brick fence and you can stand on it. Parentheses when you can't actually stand in that spot. So again, domain goes this way. How far left? How far right? Then range. So range goes up and down. So we're looking at our y-axis for range. And looking at our y-axis for range, we're trying to decide how far up does the graph go and how far down does the graph go. Hopefully you've already seen this arrow is pointing up, this arrow is pointing down. So that means that at no point is it going to hit a ceiling or a floor and stop. There's no, like, if this had been a point, then it would have stopped there. But because of these arrows, it goes on indefinitely in both directions. So this is our positive infinity. This is our negative infinity. So then the range is going to go from positive infinity to negative infinity. You're using parentheses again because you can't hold an infinity or touch an infinity or stand on infinity. Negative infinity to positive infinity, and they probably will be written the other way. Sorry, I'm talking and not paying attention to what I'm doing, but it's fine. You still know that it goes in both directions forever. Will also be called all real numbers. And that just means all y values are present because this is a line and all these are like little dots that just melted together to make a line. So all real numbers, and that notation could look like this. Again, the cool and not cool part about Math 3 is you've had so many math teachers and so much math that there's lots of different notations that can happen. Deciding if it is a function. So a function is your vertical line test, and deciding if any x values repeat. And in this case, they most certainly do. It definitely touches twice. So in that case, it is not a function. And as soon as you have not a function, then it cannot be one-to-one. It does pass your horizontal line test. So if this was an inverse, we could call it an inverse function. But no, it is not one-to-one. It only passes the horizontal test. All right, again, so domain and range. This guy is because it ran off the page, you can assume these are arrows. Assume these are arrows. If it is a stopped function, it will have a dot. Like you will see a point there. So again, domain is going to be our left to right. So we're looking at this. But again, if we have arrows going this way and this way, that means it's going to go this way and this way forever. Positive infinity, negative infinity. So our domain, again, is going to be that all real numbers, which, again, is negative infinity, positive infinity. And that's just a notation difference. The same answer, notation difference. And the only reason I'm trying to show you all of them is different programming. It just depends on the teacher, the worksheet, the test, the outlet that you're using for instruction. So that's going to be it. Range, up and down. So again, they're going up and they're going down. So it's going to be all real numbers again. Negative infinity, positive infinity, parentheses because you can't hold it. Is it a function? So does it pass the vertical line test? That's a yes. Is it one-to-one? Does it pass the horizontal line test as well? That's a yes because the line did not touch. So none of the y value, there's no turn back, or there's no turn down, or there's no swivel up or swivel back. So the x values do not repeat and the x and the y values do not repeat. So it is a one-to-one function. So our domain for this guy, so this is negative infinity, this is positive infinity. So domain, again, we have both arrows, which means it's going to keep going left to right. So our domain is going to be negative infinity to positive infinity. Again, also known as all real numbers. Also known as all real numbers. Your range, now that is up and down. So remember, that is up and down. So we're looking this way. Looking at our range. This graph goes up forever because our arrows are still going this way. Down here, though, this is a spot. Like it stops right here and only goes up. So it's going to stop at -3. That is the lowest point. So it's going to go from -3 to positive infinity. -3 is part of the function. So you're going to get a bracket because that is a brick. And then positive infinity to the top. Is it a function? So that's horizontal line test. So going this way, do the x values repeat at any point? That's a no. So then yes, it is a function. Is it one-to-one? So is it going to follow, does it pass a horizontal line test? And that means none of the y values repeat. As you see, it's a quadratic. So we're touching, multiple times all the way down. So no, it is not one-to-one because it does not pass the horizontal line. Does not pass horizontal line test. All right, again, this is all pretty basic. I am going to probably end the video here, and you'll have a second ed puzzle for the other one. Those of you in class, thank you, and we'll just keep on boogieing, and I'm going to move right on. So if you have problems with domain and range, I need you to let me know. There is going to be more practice the next couple of days, but again, you've been doing domain and range definitely since 9th grade. But I do know some of us struggle with it. But I want to get through as much different curriculum today as possible during our lesson, and we're down to about 5 more minutes. And increase, decrease, positive, and negative, I have found for most students is a little complicated. Not once you get used to it, but you haven't been doing it since 9th grade. So it's a newer concept. So I want to spend our time using the newer Math 3 concept per se. All right, so I'm going to skip these guys at the moment. If we have time, we will come back. So I picked quadratics because we've done quadratics since you were freshmen, for sure. So this is going to be, so everything above the x-axis is positive. Everything above the x-axis is positive. Everything below the x-axis, I bet you guessed it, is negative. So everything, and we're looking above and below. So this is our negative. The one common misconception and common mistake is because we're looking up and down for positive and negative, you think you're going to use y values. Never. Positive, negative, always going to be x values. Always x values. We are setting many domains. Many domains. So always x values for positive and negative. Now, increase versus decrease. So increase versus decrease, we're reading from left to right. So increase or decrease, we're reading from left to right. And we're looking, is the line going up? Now, most of you guys get confused because these arrows are pointing down, so you tell me this whole thing is decreasing. It is a negative quadratic, but the whole thing is not decreasing because, again, we're reading from left to right. So as I cover it up and I go like this and I start to find my function, there he is. As I'm going from left to right and I'm revealing more of this function, is that line increasing or decreasing? So the definition of increase is that when the x values increase, so when they get bigger, so again, reading from left to right, then the y values increase as well. So as you see, it was -8, -6, -4, -2, -1. As my x values will say were -3, -2, -1, 0. So from left to right, x values were increasing, y values were also increasing as I went to this point. If I keep going, now I see that it turned down. So now it's going down. So again, the definition of decrease, again, you're reading left to right. So as the x values increase, because we're setting domains, and we're reading from left to right on the x-axis, as the x values increase, the y values begin to decrease. So as x gets bigger, y gets smaller. Again, so we had -1 and then -3, -4, -5, -6, -7, -8. They were consistently getting smaller. So increase is going to be going up from left to right. This is your increase. You're going up a mountain. And then decrease is going down a mountain. And again, just speaking to quadratics because I feel like you guys are more fluent in them. You'll have a turn point. Like I always like to call this the turn point. It's very important where it is on the x-axis. So in this case, my x-axis, the x value is 0. So then it's going to increase. Remember, these are arrows, which means it's going left and right forever. So it's just going to continue to go out and continue to gain x values in either direction. So by increase, this is our negative infinity. This is positive infinity because we're only focusing on the x-axis for increase and decrease. So increase for our pink values is going to start at negative infinity, parentheses because you can't touch it, and it's going to continue to increase until I hit 0. This is a parentheses because when you're standing at the top of a mountain, are you going up or are you going down? You're not going either direction. You stopped, like you're turning. You're making a change. So it's not a brick, so it's not a bracket because at 0, it is not increasing. That's where it stopped increasing and it's about to flip the other way. So from negative infinity to positive 0, it is increasing. Decreasing is going to start at 0, parentheses again, because when you're standing still, you're not running up a hill or running down a hill. And then I'm going to start running down this hill indefinitely, so that's going to be positive infinity. So 0 to positive infinity as it's going down. For the conversation of positive, negative, this graph, the whole thing is negative. So this half is increasing in the negative because it's in the bottom half of the graph. This half is decreasing in the negative because it is in the bottom. So if it was to say what interval is this graph negative, that would be the whole graph. So negative for this guy would be from negative infinity to positive infinity. Again, reading your x values. So you're always setting up many domains for negative and positive. Back to this guy, when is this one negative? That would be never. This is all in the upper quadrants of your graph. So it is positive. And I misspelled positive, sorry. Positive, again, from negative infinity. So all the values going this way and this way to positive infinity for this first graph, because it's all in the upper 1 and 2 quadrants. For increase and decrease, this is opposite of the other one. Here's our turn point. I like to put dots there, so that makes it a little easier to see them. So from left to right, this is decreasing in the beginning. Contrary to that arrow, remember you're looking from left to right. So as x gets bigger, what's happening to my y value? So I'm tracing my graph from left to right. So that's my decrease, and it's going to decrease. This is negative infinity. This is positive infinity. So it's going to decrease from negative infinity to 1. Whoops, right there, sorry. So it decreases from negative infinity to 1. And then this side is increasing because as the x values increase, the y values go up. It's going to start at 1 again, and it's going to go up to positive infinity. Now, they will not always be infinities, and they will not always be the simple because, again, this is a quadratic, which you're already really, really comfortable with. All right, guys, so I'm out of time, but increase and decrease, I will fill in the rest of this worksheet in the event you want to mess with it and then go look at it, and probably post the answer keys next week sometime so you have plenty of time to work through it if you want to as extra practice, or like I said, just to check back and see if you realize right before your quiz that you don't know what's going on. This is a great reference point. All right, guys, have a great day.